Part 3 of this video is going to pick up on number 2, letter C. So we are looking at letter C on number 2. Letter C has a shape like this. Go ahead and draw this in your paper. Okay, what we have are hash marks here. That means these 3 sides have the same measurement. Let's go ahead and call this 10 millimeters. So if that's 10, this piece is also 10, and this is also 10. So now we're going to put 2 hash marks over here and make these 2 equal, and we will make these 20 millimeters. Now again, we have a shape that is not on our formula sheet, and it looks like a chunk has been taken out. So I'm going to do this one like I did the last one, and first figure out a large rectangle, as if I were putting carpet on this entire piece, and then I'll have too much and I'll take a piece out. So the area of that rectangle is length times width. If I look at this picture, the width here seems to be 20, but let's figure out how long this rectangle is. There's no number along the bottom here. So we have to use our detective skills and see if we can piece something together from the clues in the picture. The only other number that's in this picture is this 10 that's up above. Now I know that's much shorter than this long piece here. But what else do I know? I know that because that's 10, this is also 10 right here, because it has 1 hash mark. And because those are both 10, this is also 10. Now, if you look very carefully, watch what I'm going to do. I'm going to take this piece, and this piece, and this piece, and stack them side by side. That one is about that long. This one is this long, and this one is this long. If you notice, putting those 3 pieces together, those 3 pieces are the same length as this. So if I add this 10 plus this 10 plus this 10 all together, side by side, I get the length of this bottom piece, which would be 30. Again, this piece plus this piece plus this piece added together are the same size as this. And that gives me the clue to the bottom of my rectangle. So now I can go and fill this in. This length is no longer a mystery. The length here is 30. So to find the area of that large rectangle, I do 30 times 20. I get 600 millimeters squared. I'm not done, because what I've done is figured out the area of a large rectangle. Now I have to figure out the area of the chunk. This is a chunk that I'm going to cut out of my large rectangle. So let's move forward and figure out the area of that chunk. Now, it looks like I've forgotten to put some information in the picture. So let's go ahead back to the picture and pretend that originally I had a number here, and let's make this number 5. Okay? Now I can look at this blue rectangle and I see the length and I see the width. So for my blue rectangle, I've got length times width, I've got a 5, and I've got a 10. The area of my blue rectangle is now 50. 50 millimeters squared. Again, I started out with a very large red rectangle, and I took a piece out. So to find the composite area, what I need to do is subtract. What am I subtracting? I'm subtracting from this big, huge rectangle, this little chunk that I took out. So when I do my work, the composite area of that figure is the 600, which is the large piece, minus the 50, which is the little chunk that I took out. Altogether, I have 550 millimeters squared for that shape. Now to switch gears and move to problem number 3. If you notice, it says perimeter, and when I see the word perimeter, I think of fence. So now I'm looking at the outside of my shape. Let's look at the shape that we have for problem 3A. Again, there's no shape like this on my formula sheet, but I do know that perimeter is the outside of my shape. So let's make this 5 centimeters and let's make this 10 centimeters. Okay, now if I'm building a fence, I have to remember that I'm including all the sides. So far, I've got perimeter equals, and what I have is this piece, and that piece would be 5. Plus, I've got this piece would be 10, plus, remember I need to enclose the entire shape, so I'm looking at this side. That side is the same as this side, so I need to add another 10, even though there's not a number here. I know that that's 10, so I'm going to add another 10. Now the problem with this picture is now I have a curvy shape. This curve right here is not the same length as this straight line here. So the only shape that I know to find a curve on my formula sheet is a circle. And if you look at this dotted line in your picture, let's draw a dotted line. Do you notice that that looks like a half circle? So, what do I call the distance around the circle? I call that circumference. Now, there are 2 formulas for circumference on my formula sheet. I have a formula where I use the diameter and a formula where I use my radius. Let's look at this circle. We have this piece right here. That's a diameter. So what I want to use is the formula pi times diameter. What I have is 3.14. The diameter of this is not written in my picture, but if you look, you'll notice that this is 5. If that's 5, then this line also up here, which appears to be the same size, would be 5. So my diameter is in fact 5. So if we multiply that out, we get 15.7. And that's the circumference of an entire circle. We want to divide that by 2 because what we have up here is a half circle. So 15.7 divided by 2 gives me 7.85. So this distance around here is 7.85. Let me ask myself if that makes sense. It appears to be longer because it's curvier than this. This is 5, that's 7.85. It makes sense. So let's move back up here. I want the distance around the total shape. I've got 5 plus 10 plus 10 plus my curvy piece of 7.85. Let's now take these numbers and add them all together. What I end up with is 32.85 centimeters as the distance around my entire shape.